Lesson 5.3 rates. Today's lesson is a pretty big review of some stuff that you've done before, as well as a little bit of an advancement in vocabulary primarily. Not really in any sort of mathematical skill, but an advancement in vocabulary. So let's take a look. Rates. A definition for rate is the quotient of two measures with different units. This is a key here, different units. Whenever we're talking about a rate, we generally include the word per. Sometimes it's substituted for each. 25 miles per hour, for example. A common way when we're operating with rates to write them is in fraction form. 25 miles over 1 hour, or 25 miles per 1 hour. In this case, the 1 is implied. Since a different value wasn't indicated, it didn't say 25 miles per 4 hours. We just assumed that there was a 1 indicated. For another example would be to talk about Tanya and Gary. They drove 400 miles in 8 hours during a trip. If we wanted to find a rate in this situation, we would just compare the two different quantities with two different units, miles and hours. So here we could take a look, 400 miles over 8 hours. Now, we could potentially do 8 hours over 400 miles, but in my mind, I think that miles per hour makes more sense than hours per mile. Both of these rates could potentially be useful, but generally we go with the one that is more often used. So 400 miles per 8 hours is the same as 50 miles per 1 hour, or again, 50 miles per hour. We usually decide which seems more likely to determine if we're going to do 400 divided by 8 or 8 over 400. So why don't you go ahead and try it. Calculate a rate given the following. In this case, we could indicate 1 2/3 inch per hour, or we could do the division the other way and indicate hours per inch, and we might say something like 0.6 hours per inch. Reciprocal rates involve the idea of flipping them around, rates that are reciprocals of one another. For example, we could do miles per hour or hours per mile. We can calculate both rates or reciprocals indicated in the following statement. On average, Emilio goes through 4 pencils every 3 weeks. One option would be to consider pencils per week. 4 pencils per 3 weeks would indicate 1 1/3 pencils per week. We could also use the reciprocal rate where we do weeks per pencils. 3 weeks per 4 pencils, which would indicate 0.75 or 3/4 weeks per pencil. Depending on what you're trying to do with the rate, one of these may be more useful than the other. Neither one really stands out as being correct, so we could use either of these rates. When we talk about rates, we always have something called unit rates. A unit rate is a rate in which the denominator is 1 of some unit. For example, 4 pencils per 3 weeks, the unit rate there is 1 1/3 pencils per week, indicating 1 week. 400 miles per 8 hours would be a rate. However, we would probably do this as the unit rate of 50 miles per hour. Let's talk a little bit about negatives and zero in fractions. We've talked a little bit about zero in fractions, and we'll continue to talk about that. But let's begin with negatives. In general, for any numbers a and b not equal to 0, because what we have said about 0 is that 0 cannot be our denominator. The opposite of the fraction a over b is the same as the opposite of a over b is the same as a over the opposite of b. If one part of the fraction is negative, really the entire value of the fraction would be negative. But if we have something like the opposite of a over the opposite of b, it's equal to a over b. If two parts of the fraction are negative, the entire fraction is positive. It indicates a positive value. This is very similar to multiplication with negatives. When we multiply with negatives, an even number of negative values indicates a positive value. Whereas when we multiply in negatives, if we have an odd number of negative numbers, we would indicate a negative value. So take a look at the following 5 fractions. Which of the numbers represented is not equal to the others? Go ahead and press pause and take a moment to do this. The only one with an even number of negatives being 2, making it a positive number, is the center one here. Here this one negative indicates that the entire value is negative. Here this one negative indicates that the entire value is negative. Here this one negative indicates that the entire value is negative. In this case, we have an opposite, which would indicate a positive value with one negative, indicating an entire negative value. Let's take the time to talk a little bit more about zero in fractions. In general, a fraction cannot have a zero denominator. Think about if you were traveling 10 miles in 0 hours. 10 miles per 0 hours, it's impossible. Really, you'd have to be in 2 places at the same time, which tells us that 0 really cannot be in the denominator of a fraction. If a variable appears in the denominator, we must assure that the value of the variable doesn't zero out the denominator. For example, the following fraction, this one right here, is undefined if x equals -4. Because if x was equal to -4, our denominator would become 0. -4 plus 4 is 0. The same fraction, this one right here, equals 0 if x is equal to 0. If our numerator is 0, that would just indicate that the value of the fraction is 0. So a numerator 0 is okay. A denominator 0 is not okay. So taking a look, try to determine which value of x would make this fraction undefined and which value of x would make this fraction equal to 0. X equals 3 would make this undefined because then the denominator would be 0. 3 minus 3 is 0. X equals -2 would make this fraction equal to 0 because that would give our numerator a value of 0. And that is what we're taking a look at for right now for notes. So we'll do a few more examples. When I see you guys next time in class, please be ready to ask some questions.